What's up, Louie, man? How's your weekend?
Yeah, it was a really interesting weekend. You see, I was surfing, and all of a sudden, a wave just took me up, and I really hurt my leg. I might have broken it or something, and then I was taken in an ambulance, and I drove by a lady, and I saw her. She got really startled, and it just really got me thinking: does the frequency of sound waves produced by the siren change as a car drives past somebody?
What do you think the Doppler effect is?
I think the Doppler effect is a scientific study developed by Laura Remus last year. Quite impressive, and it really looks at Dopplers and meteorologists in a very interesting way.
What do you think a wavelength is?
You know, I've been surfing for a lot of years, and there was this one time where my buddy got a piece of coral stuck in his leg. I said, "Oh, you got a piece of coral stuck in your leg, dude, you gotta go to the hospital." He goes, "Dude, the wavelength, it's coming though. The wavelength's only like 10 feet away. I gotta get the next wave in." I said, "Yeah!"
What do you think frequency is?
Frequency, it's a very peculiar thing if you ask me. Frequency is when something like keeps on happening or something like keeps reoccurring.
What do you think?
He's in physics. Is the Pope Catholic?
Are farts stinky?
Yes.
Before we begin to explore the Doppler effect, we need to understand a few things first that will help us better explain this theory.
A wave is a disturbance that repeats regularly in space and time. Waves are transmitted progressively from one point to the next with no net transport of matter.
Frequency for a wave is the number of crests, troughs, or successive identical points that pass a particular point per unit time.
Okay, so we made two observations in our experiment. The first observation that as the car drove closer to me, the wavelengths thus decreased, thus increasing the frequency of each sound. Then, as it drove past me, the wavelengths began to increase again, thus decreasing the frequency. The pitch of sound increases when the source moves towards you and decreases when the source moves away. When the vehicle approaches, the pitch is higher, like a higher note on a musical scale. This is because the crests of the sound waves encounter your ear more frequently.
And when a vehicle passes and moves away from you, you hear a drop in pitch. This is because the crests of the waves are hitting your ears less frequently. The Doppler effect is the change in frequency due to the motion of the receiver or source. Oh, hey Lou, I didn't see you there, man. Picture this scenario for me. You're standing in the JPL, waiting for a friend to come pick you up, go cruise, go to Cordoba, Pink Bear, whatever, same old thing. And a car drives by with you with a siren on. And then another one even faster. And it got me thinking, does the velocity affect the frequency of the sound waves produced by a siren?
At the club, gonna say what's up, took her to the crib, yeah, two little booty, that's why I two little booty, whoa, whoa, hey. Hey.
broken or something. But it just really got me, this weight. In fact, speed does not affect the pitch of sound increases when the source moves toward you and decreases when the source moves away.
Is it towered? Before we begin to explore the Doppler effect, we need to... Fuck, what do we... You're laughing before me. wait, let it roll. Let me laugh it out. Before we begin to explore the Doppler effect, look, I hate you. Let me see it. Before we begin to explore the Doppler effect. Why is it so funny?
I don't know. We can't. Oh, I hope I get a 50 on this physics lab. Please.